Firstly, thank you very much for the introduction there. I would like to thank Argon. This is an amazing opportunity to come over here from the UK and see all you lovely people in the States. It's going to be a great sort of, like I said, I've had personally a couple brilliant days with the education, and hopefully we can carry on that through now. So, like I said, today we're going to just cover some RPDs. So again, something we've been doing in the UK at Skillbond. What I'm going to do briefly is just give us a quick introduction. What I do personally, what we do as a company, and obviously how we're associated with Argon. And then we'll go through some quick presentation. And then obviously we'll go into a bit of live demos today too with the 3Shape. So, but no, brilliant. So obviously just to give you a brief introduction of myself really. I was born and raised obviously in South Africa. I came over to the UK in 2002 and obviously qualified as a dental technician back in 2005. Can you hear me okay? Better. Thank you guys. And yeah, I come from a sort of a third line generation. So I'm a family of technician. My uncle's a technician, my grandfather's a technician. And so that's where the journey's really started. So like I said, so it's been about 20 years qualified. Obviously, I got my first 3Shape system back in 2010. And since I've joined my current position at Skillbond, obviously I'm accredited 3Shape trainer as well. Especially with the removal background myself, obviously we've got lots of advanced courses we run. I've been lucky enough to obviously go out to 3Shape ourselves, obviously, and do many advanced courses out there in Copenhagen. So just to give you, obviously, outside of work, what I love doing really is basically, I was lucky enough to come over here to Argon in San Diego in December, and basically, in a nutshell, I think I love your country. You guys have got such an amazing country. I toured around for a month, and I think you guys, and so I personally love to travel. I love to get around, and I think, like I said, you guys are such a lucky bunch to be able to have this on your doorstep. So amazing. Just to give you a brief background where we are in the UK, so Skillbond itself, that's our headquarters there on the left. And obviously that's where we are based, just outside London, 20 minutes from Heathrow. So obviously we got a digital outsourcing center. Obviously we're a sundry company ourselves. Simon Richards on the top there. He's obviously our managing director. He is around here, so if you do see him, obviously say hello. But obviously we've been a dental company since 1973, and we're into our 50th year in the industry. We are the largest dental supply company at the moment in the UK. We've got about 120,000 different products. And we've been part of the Argon Corporation since about 2001. After Argon started their digital journey, we began ours in 2014. So in 10 years, we've become the largest digital manufacturer in the UK, and we just served at UK dental labs. So just to give you a brief background of my, obviously, working day, typical working day. Like I said, we are a 3Shape reseller, so we support over 425 UK dental labs with 3Shape. We are the biggest 3Shape reseller in the UK. And we offer a full range of digital products to the UK dental market, sort of averaging about 1,200 units a day. And that ranges from copings, crowns, RPDs, dentures, so a full digital service we offer to our UK customers. We also offer 14 dedicated digital courses, and we saw over 500 technicians last year come through our doors. So like I said, we've really got a great understanding, especially when we start moving into the digital RPDs, which we'll talk about a little bit later. We're also very proud, like Argon itself, we pride ourselves on our support, and we were also sort of privileged enough to win training provider last year, as well as aftercare provider. So that's something we're very proud of, and I know Argon itself is obviously that's what their belief says as well, and we do like to support all our customers and sort of hold their hand through the journey. And like I said, we like to be an extension as part of the lab, so obviously help them through the digital journeys really. So moving on, so we're just going to have a quick couple slides. We'll run into, like I said, just explaining what the RPD market is. But again, I think we see this. I've been going to a couple lectures over the last couple of days, and we've seen this. Digital dentistry is not the future; it's definitely the present. Especially with the amount of RPD topics, digital dentures we've covered over the last couple of days. It is amazing to see where we are. So, intraoral scanners are driving digital dentistry. Obviously, I've just seen personally how it's grown over here in the States, but we've seen it in the UK as well. like you said, last year we saw cases grow by 66%. We work very closely with 3Shape in the UK, and we've obviously seen a major pickup in iOS usage, especially in the full denture and partial denture workflows, and I think it's going to continue to grow. Obviously, another positive that's obviously coming out from obviously where we are now, with especially moving into the RPD manufacturing process, is that 3D printing and the additive technology is obviously growing at such a rapid pace. But obviously, like I said, 3D printers are now the hottest equipment in the market. And also, like you said, it's become a true game changer for, like I said, the materials, the technology. It's allowing us to produce more products that we never used to be able to in the past. So. And obviously, I think why you guys are all here as well, like I said, digital RPDs, along with the digital denture workflow, is the fastest growing area in digital dentistry. We found, obviously, just ourselves as an outsourcing center in the UK, those that have been outsourcing to us have reduced their normal production by 60 to 70%. And that's with them creating designs in less than 15 minutes. If you're a lab that produces RPDs, this is now the time to get started, because I think, like you said, there's such an exciting time to go. So just to obviously give you a quick workflow, obviously, what is the workflow for producing a digital RPD at the moment? Obviously, you got the scan element, which is obviously either intraoral or model scanning. Obviously, then you have the CAD design, which is obviously, you can choose whichever platform you're looking to use, your 3Shape, your Exocad, your Saronas. And obviously, you need a manufacturing process too in the CAM, which is obviously subtractive or additive. So we're just going to briefly just explain those quickly to you now. So obviously, the first one is obviously the subtractive manufacturing process that a lot of us are used to if you're milling in-house or you're sending to an outsourcing center. The pros of this is obviously you've got a various range of materials. Like I said, obviously none of those are going to be perfect for metal RPDs. But obviously the one positive from there is obviously you can get a very smooth, clean finish. But if you look at the cons, they definitely outweigh the pros by a long way. So obviously the problem with milling is you're going to have a considerable amount of waste and unused raw material. It takes a lot more time. Again, not effective or economic for large full undercut cases. So if you've got any sort of complex milling parts or patterns, or you can't mill at sort of 90-degree angles, then you're going to have a lot of problems. So like I said, especially for complex designs and large cases, you're going to have limitations. Another big thing for labs is obviously the wear of the milling tools and the spindles. Obviously, the maintenance of the equipment, it does cost a lot of more maintenance, more repairing, wear and tear on the bows. And obviously, there's, like I said, if the designs aren't correct, you might have chips and fractures, which could occur during the machining process. They are still, like I said, people are using the subtractive process for RPDs. And just to give you guys a brief sort of overview, you can mill your sort of acetyl resins. All these previous sort of products used to be maybe injectable, but now you can all get them through sort of milling through pucks, and obviously sort of acetyls, thermoplastics, and your flexibles. You can mill them also out of directly from the pucks. PMMA, I've already seen a couple these couple of days. Obviously, we've heard about Evotion. We've heard about the different sort of processes and companies with this as a tried and tested. And obviously, you got the various other products like PEEK. You got your PEEK and your hybrid polymers too that have obviously evolved into the digital RPD market as well. But where we're probably going to speak more about today is obviously we're going to talk about SLM, because obviously I think SLM is the only product available for making partial cobalt chrome dentures at the moment. So additive, as you can see, the pros with that additive is obviously material efficient, resource saving. You're going to get a faster route from design to production. You can create the complex geometric designs easily and accurate. And I think that's where it comes into its own, because obviously any sort of shapes, any sort of patterns, you can definitely SLM, 3D print. It's a bottom to top process. So as you can see from the image, like I said, the laser just touches and fuses your pattern together, and obviously you can create whatever sort of shape, whatever pattern, but also it's highly, so if you do have a very large, tall, different palettes you're thinking of, like you said, you can definitely 3D print it, no problem. But also it's a passive production process. So like we said, there's no wear and tear and costs involved with machining. And again, there are a few cons, like you say, there is a limited range of materials at the moment, but again, for cobalt chrome, it's perfect. And also there is a small element of surface finishing, because obviously it's not as smooth as milling, But obviously, again, it's still cutting out a lot of labor, which we're going to go into just now. So just to give you an idea, types of RPDs using the additive process. Again, we can do 3D printed denture resins. There's a lot there on the market at the moment. You got your monoblock try-in resins or your flipper type dentures. You can, obviously, if you guys still invest in casting machines, you still got casting machines yourselves in the lab. You can print in a casting machine in a castable resin and still invest in cast yourselves. Or again, what we're going to discuss today is obviously the SLM, the SLS. And I think this is the most obviously unique option available, because obviously this is the only one that we can do to metal is still going to be around for a long time. And obviously, like I said, sometimes you can't avoid a metal RPD. So this is the only process that we can actually digitally manufacture them from start to finish. So as we said, selective laser melting, as we call it, SLM, is an additive manufacturing process where the object is built layer by layer, as you saw from the image before the movie there. Again, it's powdered metal, cobalt chrome alloys fused together, 30 microns to avoid many issues associated with the traditional wax and the casting method. As we have no plastic patterns, and casting means that unparalleled consistency. And that's the key benefit here, because you can always get that consistent result. You're going to get precision all the time. There's no other variables that can make or add that can make this process go wrong. So as you can see, if you've designed right, which we're going to do just now, you should get a good result with obviously companies like ourselves, or Argon now just about to release it as well. So like you said, you'll get a very consistent result if you follow the correct stages of the design protocols. So just a little slide there just to give you a short historical overview of additive and obviously where we are when it comes to SLM and SLA. So as you can see, back in 1984, just to give you an idea, we're talking about 40 years in the industry, obviously when SLA was invented by Chuck Hall there, but to see where we've come now. But the biggest game sort of changer, I think, was in 2011 when companies like 3Shape, Exocad, they actually designed a dedicated RPD CAD software, which again allowed us to design these partial frameworks digitally, and that's allowed us to then obviously have the corresponding manufacturing processes like the SLM machines, the concept lasers, which obviously can produce these and then obviously produce a fully digital SLM partial denture. Again, the question we ask all the time is, so why digital? Just to give you a brief overview of the steps, I think if you guys do these by hands yourselves and use the analog method, as we can see, from surveying to making duplicate models, waxing up, spruing up, investing, furnace time, casting, sandblasting, trimming, electropolishing, to the final finish, there's a lot more stages that you're going backwards and forwards, which is obviously for you guys in the lab is obviously highly important, because we're trying to cut down that labor intense, make it a lot more user-friendly for you guys. So, and if you look at the digital steps, there's a lot more, the footprint is a lot better. So obviously we can acquire the scan either by iOS or desktop scanning these days. 3Shape got a great software, which we're going to talk through. We'll go through the stages just now. Again, send it off for your laser sintering. There's only a little bit of surfacing. Obviously, we've got to cut the supports off and the sprues and obviously just do some surface finishing, trimming. These days now, obviously, with the digital workflow, you've got machines like this here, the OTEC, which is obviously a rotator, a polisher. So again, we all know how long and hard it is to polish these things up to a high standard. And again, you get a quality finish at the end of it where you know that you're going to get unparalleled results, you're going to get better fits. So just to show you how many stages we've cut out, just by that. So I think if you guys are doing analog and casting your own chromes yourselves at the moment, you can see you can cut the steps probably by half or even more. Like I said in the beginning, most of our customers sending to us are cutting their labor costs or their labor times down by 66% at the moment. So again, just to obviously, before we get into the 3Shape designing, like I said, we're just going to talk about digital versus analog, the key benefits. So again, that's the massive one on the left. We've got the less labor intensive, shorter process workflow, keep control of the designing in-house. I don't know what the market's like in the US at the moment, but in the UK we have got a big lack of experienced technicians, especially in the cobalt chrome department area. So if you guys can control yourselves, or at least have experienced technician teaching younger generation of techs how to design correctly, that's such a key benefit at the moment, because like you say, we've got a real shortage, and the experienced cobalt chrome labs out there in the UK are obviously either at full capacity or they're going to have to obviously increase their turnaround times by so much. So like you said, this is another sort of solution for helping you guys out there. So again, there's a reduced investment of maintenance costs for expensive furnaces these days, casting equipment, less wasted material resources. Like you said, you just got to think about all the alloys, the waxes, all the other extra little sundries you get along with it. This is quite an important one too, because obviously you can share designs these days and information between the technicians and the clinicians. So softwares like 3Shape and Exocad have their Trios inboxes and their community, so you can share them all via cloud. So it's all patient data and GDPR regulated. And again, you guys can design something, 15 minutes, 20 minutes, send it to your dentist or clinician, and they can send back an approval. And like I said, or any adjustments that's needed. So again, it's just working the whole digital workflow, which is great. So obviously, just to go along with all the obviously the less wasted materials, obviously can improve the health and safety, all the trimming, not having the investment, the polishing, breathing all that sort of nasty stuff in. And again, that leads on to obviously the potential reduction in environmental impact as well. But also, here's another great one, is obviously the ability to recall, change design, and remanufacture without the need to start the process again, which, again, leads to the less labor-intensive, saves you guys time, money, effort. As we know, time is such a money spinner these days in the dental labs, especially after COVID. So if you can have your design on the screen, you guys just need to change it, recall it. You've got little apps and like Smile Designs these days, which can all help you. It's the 3Shape, the Exocad are definitely leading the way with that. So. And also gives you an option to enable you to start your RPD workflow with virtual teeth, which again, we can't do an analog. So you could do a try-in. You can have your try-in done, or Smile Design, or your digital diagnostic mock-ups, which again can help you when you're doing your treatment plan, designing class, designing sort of designing posts, backings. You can have all that done prior to you actually getting into designing and actually sending off that SLM STL for manufacturing process. So you can do all the planning right up to, like I said, it's cutting all that time. You're not having to send try-ins backwards and forwards. So again, just to give you guys, before we get to 3Shape, is obviously just the requirements. I think obviously if you guys are using 3Shape or Exocad, obviously you need to have the right software to use. So either you need to have an RPD software standalone, or obviously, like I said, the complete package that 3Shape do, the complete restorative, which is ideal, I think. I think in the modern day dental lab, you guys will be probably finding there's a crossover on 3Shape. There's a lot more crown and bridge elements coming into the RPD designs. There's a lot more you can do with that. The gingivas, the pontics, adding pontics, which I'll show you as well. Again, just bear in mind, if you don't have the complete restorative, you do use things like CAD points. So CAD points is obviously a top-up by 3Shape there. So obviously it will use 15 CAD points for every save. So again, maybe the initial investment, if you're only doing a few CAD points, is a good solution for you guys to test the water. But definitely I would look at investing in the complete restorative package so you don't have to hit those hurdles when you come to them. 15 CAD points can be a lot of money if you're doing 10 RPDs a month. That can definitely rack up in costs. This is probably the most important one when we talk about, especially when we're talking about the SLM RPDs, whether you guys are going to send to places like ourselves or Argon. It's having the correct DME file. So the DME is the digital media exchange file, and this obviously controls and contains all the material, obviously specific parameters. So these parameters are essential because obviously we need to make sure that you're going to be sending a model-free STL to a company to produce an SLM framework. You need to make sure that all the major connectors, the clasping, the jumpers, they're all totally correct. So having that DME file in, so ideally, you would either contact Argon itself, and they would obviously provide you with that DME file. They can install it onto your 3Shape, and then obviously that will allow you to design, and at least you're designing within their parameters for manufacture. We also advise obviously customers to have obviously completed the 3Shape level 1 courses, or like I said, in the UK we have a level 1, level 2, level 3. So we try to get people to obviously from intermediate to advanced users, because again, it's quite a jump up. And we definitely don't want people to be overwhelmed when they do sort of start to come on these courses, because there's a lot more designing involved. It's not just designing basic coping. So like I said, it is quite an advanced process. So we do try to keep the sort of users up to an advanced level, intermediate to advanced level. And also, like I said, I think Argon, like ourselves in Skillbond, when you send the first cases through your Argon link, I think the best thing is to contact support so we can check the designs together before uploading. This will also then stop you guys obviously having any bad files, rejections later, and obviously delaying your process you're in. So it's always good for those first couple. As I said, we like to hold your hands. We like to be an extension of your lab. I know Argon's got brilliant support as well as we do. Give us a call and give us a shout, and like you said, they can jump on and have a look and run through those design protocols together. So, but right, so that's all great, guys. So what we're going to do is I'm actually going to jump into the 3Shape now, and actually now we're going to run through a partial, and hopefully there we can go through all the different stages. Hopefully you guys might be designing partials at the moment, but hopefully there'll be any tips and tricks you guys can pick up, and obviously we'll talk about obviously how we're going to produce a proper, fully functional fitting SLM RPD denture. So I'm just going to come out of that. So start the order form. So I'm going to do an SLM RPD today. So something that we could be used to, and as I said, we can obviously incorporating the crown and bridge workflows as well. So maybe we want to do, like I said, a workflow for possibly a backing or a metal dummy, as we call it sometimes in the UK. But I would highlight a tooth. And obviously what you can do is you can incorporate actual pontics. So you can't incorporate the crown options, but you can definitely incorporate either full anatomy pontics, or you can actually obviously a cutback. So obviously if you want to do layering or composite layering, or maybe you want to do some wraparound and tension in there. So I'm actually going to obviously select an anatomical pontic for that tooth element. And then obviously we can go double up on the workflow page there and actually go to removable. So if we click on the removable, as we said earlier, the DME is the most important, so finding the correct DME. So obviously when you've downloaded it or Argon's given it to you, it's called Argon SLM RPD finished. We only do a finished option at the moment. And then because we selected Argon SLM RPD finished for the removable option, it's automatically changed it to the frame as well. So again, this is where you guys can choose whether you're scanning into your antagonists, or I'm just going to put a model there, and obviously I'm just going to take the antagonist off. I don't have one at the moment, so just to save some time this afternoon. And then obviously you can obviously put in any name you guys have, and then we can go into the scan. I'm not going to scan. I don't have a scanner here, so I'm just going to click OK, and obviously I'm going to just bring in a case. This would be the same way as you guys bring in an intraoral case. So just I'm going to go into import my scan, and I'm just going to bring in the option now for my RPD. If you guys are desktop scanning, if you guys have the E2 scanner and above, you have the option to actually have texture scanning, just like that down in the bottom left-hand side. So you can actually, especially if you guys are learning RPD designs and getting used to it, you can actually draw it on a model and then someone actually follow your design. So it's a great option if you are looking at investing in 3Shape, is to maybe look at the E2 and above, or even the new F8 out there, because obviously you can then draw your designs onto the model, and whether your IT or your CAD technician can follow it when he's actually designing it. So it's a neat little trick that. So I'm going to go right click now and go to design anyway, and I'll show you that on the big screen now. So as you can see, if you scanned your model in there, you could have your design drawn on there. Obviously you wouldn't be able to have that with an intraoral, but definitely with desktop. And again, if you needed to ever change that, you've got an option here on the right hand side which says there, show texture scan, and you can choose that. You will need to jump between texture scan and normal monolithic, because we're going to talk about the undercut and the treatment planning for clasps, because this is vital, because you don't get your undercut depth chart in texture scan, as you can see, but obviously you can definitely draw it on there and you can still follow. So what I'm going to do first is, again, most 3Shapes skip this prepare stage. I'm just going to go back to prepare, and just to give you guys a quick idea of what we can do at this stage here. So as you can see, we've got a model up, but there's just a couple little things we just need to look at this stage here. Is obviously, even though the model looks pretty much okay to me, we are going to be doing SLM metal frameworks here, so we want the model to be totally accurate at this stage. So if you do spin the model around 360, sometimes you might pick up on a couple of areas like that there. So this is obviously what we call artifacts, or it's a bit of obviously where maybe the texture's caught a bit of grease from your fingers, or maybe little lights affected it. You might see it on intraoral scans as well, but these areas here are highly important to get rid of those artifacts. And if you are using 3Shape sort of 2020 and above, you do have this option here. It says remove artifacts. It's the little band-aid option. If you click on that, you can actually go into these areas, just highlighted in red. If you play the little button, apply, what it does, it just makes it watertight. So this is highly important when we are talking about intraoral especially. So when we say something's watertight, we want the scan to be sort of solid, or have the base on it, because obviously what we're going to be doing is we're going to be laying tissue down, or we're going to be laying major connectors down. If something's not watertight, or if you hear the scans are not watertight, a good representation sometimes, if you took a sieve, even though it looks solid, maybe if you pour water into the sieve, it's going to seep through all the little holes. And that's similar to what a scan is going to do. So if you ever do hear someone talking about watertight scans, it's ideally like this is the option here, where you can get rid of all these little holes or micro holes or little artifacts. And that little band-aid tool, or the remove artifact tool, is highly important, because it just fixes up all those little areas which can cause you a little bit of a problem. So as you can see, something like that, just highlight it, hit the little play button. All it's doing is doing like a band-aid. It's just meshing it together. But at least when you are drawing your connectors, you're not going to get these squiggly lines. You're not going to get any sort of issues with errors pop up. So it's just a little tool to use there. Again, you've got options there for your sculpt. If you did need to sort of contour the tissue at all, you can sort of, some areas like that might cause a bit of problem. So if you wanted to put a bit of contouring on there, you can just smooth it down a little bit. We do have options there for attachments. I'm not going to go into too much attachments, but if you were using locators, you can choose your different sort of attachers. There's like the Rhine 83, you can actually use different attachments. So if you were designing on top of attachments, locator type dentures, removables, you can use those, incorporate them into your model. But this is a neat little tool too, is your tooth extraction tool. So again, if you're doing immediates, or you're doing any sort of options that you require teeth to be extracted, you can just click on that one with the cross, highlight the tooth you want, and then obviously just the play button. And as you can see, it's taking the tooth off totally. And again, you've got total option there to then obviously go contour the tissue, smooth it off. You can create your own socket if you wanted to. Again, quick and easy way. Before, you always had to take the model, do a scan, then go cut it off, scan it back in. But as you can see, nice, quick and easy. Really good tool to use. So I'm going to bring it back in, because I do want my tooth for that option there for the partial design. And we're going to go next. As in the order form, we selected an element of anatomy. This is the stage it's asking for us here, so it wants to know where that tooth element is going to be. So all we got to do is go highlight the 1-4 area, for the pontic area. So I'm just going to click where the annotation needs to be, and then we can go next from here. And then this is probably the most important part of the whole SLM design process, is this is obviously where we need to obviously gauge our undercut depth here on the right-hand side. And this is the color chart that obviously when we are planning our drawing our class in here, we can keep flicking between the two here, and this will help us then obviously decide obviously how much block out wax to take away. So as you can see, obviously this blue arrow coming down here, this is the path of insertion. And obviously you have total control to control that to wherever you want that. So if you're thinking about the model in your hand, how's this chrome framework going to come off? You can then obviously use the blue arrows on the left-hand side to draw, and then just obviously click and move it as it goes along by 5 degrees each time. Or if you wanted to, you can just position the model yourself, and then obviously click set from view, and then that does it automatically. So as you can see, it changes at the click of a button the path of insertion, just like you would have it on a surveyor. But obviously, it's brilliant for when you guys are designing these frameworks, so you can actually know where to put the clasps. So on a case like this, we'd probably wanted to just have it something like that. I'm just going to show you hit set from view. It's changed it. We've still got undercut to play with on each side there. And then what we do is when we go next, you'll see it will lay the block out wax on there. And again, it's a brilliant little tool. It's highly accurate. It does it all in real time. And if I top right-hand side, if you put your block out wax on, you can see it just like you've done it on a surveyor. And then obviously now you can come to using your wax knife options here. So your plus, your add, your remove, and you can actually use it to take away how much blocking out wax you want to take away as you're preparing for your clasps. So as you can see, it's quick, easy. So when we talk about SLM chromes and all the different RPDs you can do digitally, we give everyone we've got a great little guideline that we show everyone. I'm just going to get it up now. So if you have a look at the, we create a little PDF for everyone to give them. So it gives it all the hotkeys that you use for RPDs. It gives you all the sort of what each sort of distances and parameters and major connectors, the minimum thicknesses. But the most important thing that we add on there is this little undercut depth chart. And that's the chart that's up there where you can see the yellow, the orange, the red, the dark orange, and then going to red. And it just gives you a little sort of a idea on what different materials you can use in that undercut. So as we're designing an SLM RPD, we can only go to 0.25. You go beyond 0.25, you're going to get something that's going to be too retentive. Your acetals, your peak materials that are a bit more rigid, but you've still got a bit of flex, you can go up to 0.5 millimeters. And obviously any of your flexibles or your thermoplastics, you can take up to 0.75. Obviously, just as a rule of thumb, anything going beyond into the dark red above 0.75 millimeters is going to be too tight. You're probably going to get it on, or it's going to break all your models as soon as it comes off. And it just gives you a nice little highlight there, just showing you. So when you are planning your class, you can obviously follow these guidelines. So again, we want to stick to anywhere that's obviously to the yellow. That's the limitation we want to go to. So I'm just going to bring back our 3Shape now. So as we can see, when you are taking away the wax here, you can use your different options here. And you can actually take it away. So when you are planning, you can see where the color chart is. Some people like to obviously take it away subtly and just so where they can see the yellow. Or like you say, you can take it all away and then design it so you can see when the transition is going to be there. Obviously, we don't want to be taking anywhere measly or distally at this page. It all just wants to be on the buckle areas because that's what's going to keep. And anywhere where there's going to be any rest seats. So if there was going to be any rest seats, you just want to make sure that there's no block out wax, other you're going to have a non-functional rest. So like you say, we just want to just make sure that there's no, obviously, block out anywhere there. But what you can also do at this stage too is maybe instead of taking the block out wax away, you might want to sort of add some retention. Some block out wax to these sort of areas. So if you do have a anatomical, very sort of big anatomy rouge, you can actually just put it into those areas and then use the green tool just to smooth it out, just so you get a more sort of smoother transition on the palette there. So again, it's not just taking away the block out wax. You actually just obviously can add into certain areas, or maybe there's a sore spot you want to avoid, or a tuberosity. You can just obviously add some material there as well. So then our tooth has come in. So I'm just going to bring our tooth into position there. So this was for the metal dummy there. So we're just going to bring that into play here. Again, I'm just going to quickly design, put a tooth in there. Quickly get it into place. At this stage, what is quite nice too is you've got an option down here on the right-hand side, which is this little blue crown, which is additional scans. With that there, you can actually bring in a scan. So obviously you can bring in a tooth. So for maybe it was a pre-op, or in this case, maybe we had a denture try-in. So I can actually go load a scan in. So maybe we did a virtual denture try-in, like we said, so you can actually pre-plan these things. And I can bring in a denture try-in. So you can use that additional option there. So as you can see, that's just overlaid because obviously it hasn't changed the orientation. So I brought that in there, and then obviously you can then use the mirror tools and all the crown and bridge tools to obviously position that if it was a pre-op. But also, we can use these for these dentures, especially the posterior teeth there. We can actually use those for guidelines if we want to put some retention posts in the framework later on. So again, that will be there on the right-hand side. So you can always bring in that try-in at any stage. So that's quite a nice little feature there for you guys as well. But I think we're okay there with that tooth. Again, ideally you guys would have had an opposing model to run the articulation through, but I'm just going to keep that there for now. And then obviously play our contacts, and again, you can just fine tune your denture tooth, because as long as it's going to be touching the framework, it's going to mesh together just now. So let's go next. So we're still moving along left to right. So this is the cutback stage now for the little tooth there, the pontic element. If you click pontic creation on the left-hand side, you've got anatomical, which is obviously just taking off a layer off the whole tooth by 0.3 millimeters. But if you click in that little box, you've got an option here for facial reduction. And what that's going to do is just cut the veneer off there, as you can see, because we're going to maybe want to keep the occlusion element of this tooth. Obviously, maybe it was tight in the bite, or strong occlusion, so you can still keep that as metal. But then obviously you might want to have some composite or acrylic inside there. We're going to create some mechanical retention in there, and obviously as it's in the aesthetic zone, we can just bring that in there now. So all we're going to do now quickly is just drawing that red line. I can take away the model at the moment, and you can control how much you want to cut off that facial veneer. And then if you hit preview, it will always show you what you're doing, cutting away. But also, you can also, by the offset, you can increase the offset if you want, and that will show you how much you're actually taking away here as well. So you can see, you can control that totally. So maybe we'll take it up to 0.9. And then obviously, I'm just going to bring that a little bit up here. When you're using the cutback tool, it's ideal just to obviously do little by little, and then obviously hit preview each time, and you can always see what you're doing at any stage. So I'm quite happy with that at the moment. So I'm going to go next. What I'm going to do now is use the morphing tool at this stage here, because you've got your wax knives. And if all I want to do is just hollow that out a bit, because obviously we want to create some retention posts in there earlier or later. So all I'm going to do is just hover into there. And by using some of the smart keys here, I'm just going to hold control. And all I'm doing is just hovering that area in there, just to make it a bit more concave, because obviously then we can add some retention posts there later. That's okay. And then we're going to go next. We're going to go onto the SLM framework now, which is obviously the RPD design. That we can leave there for now. So as we go bottom to top now, retention grids, connector, class, and then obviously working our way down. We're going to start with the retention grids. So this is, again, if you selected the DME right in the order form, you should be able to make sure that you're following the right retention grids, because again, they're going to be designed for the right parameters for the SLM process. So I've got an upper mesh here. So as I can see there, I've got the Argon SLM upper mesh. I'm going to click on that. And click on the little box. You get your little pencil up. And all I'm going to go do here now is draw where your mesh is going to go. And then once you've drawn your square or your rectangle shape, you can actually manipulate the little dots to how you want that to be. And again, if you hit preview at any stage, it will show you what you've got. Again, I'm just going to go to the other side as well. Click on the little box, get your pencil up. And remember here, guys, this is where you can obviously, change your between the two there if you wanted to. So if you were following a design strictly, then again, you can just jump between texture scan on and off, and then just move it to where you need it to be. And again, just hit preview, so it shows you what you bring up. Right, so there's a couple of features also when you're doing the retention grid. So if you click on a dot here, as you can see, it brings up this little icon here. So again, this is where you can position. Obviously, this is just a circular mesh, so it's not, but maybe you had a diamond or a square mesh, you wanted to change the shapes or the edges. And again, if you grab the blue ball there, you can sort of position that to wherever you want that. Or like I say, you can actually spin it around to how you need it. Another neat little feature here too is obviously once you've got it into position is obviously the resin gap is set at 0.4 at the moment. So again, you wouldn't want to go beyond the resin gap to 0.4. And again, this is where digital it comes into its own really, because if we had to do a 2D cross section over that area, as you can see, that there's going to be pretty much spot on to 0.4 if I got it straight. So again, and if you went right across the board, you're going to have that perfect retention mesh there set at the resin gap at 0.4. You're not going to be sort of going below that. You can increase that if you want, but I advise not going below that. So a lot of people between 0.4, 0.6. But what also you can do at this stage is you see this little green edge you get here. So if you are coming up against a neighboring tooth, you can actually tuck that in a bit. If you hold sort of shift on the keyboard and you use your roller ball, you can actually sort of tuck that this green area in here at the moment. So as you can see, so if you are coming up or you tight for space, you can sort of minimize that area there as well, just by using shift and the roller ball on the mouse. And again, it's just creating a nice, neat finishing edge underneath. And again, always hit preview to show you what you got left with there. So again, that will work great if you had maybe just a very small area in between the tooth, something like in this area here. You could actually then, instead of your acrylic edge going up the mesial distal tooth, you can actually minimize it and shrink it right down. But we're quite happy with that at the moment, so just keep that where that is. So then we can go next onto major connectors. And again, you've got a couple options here for major connectors, but as we selected SLM in the order page, RPD, we want to keep following the same suit. It's highly important that you make sure that you're following the correct, because if this was maybe a flexible material, you could have a very thick framework. So it's highly important to keep following the correct corresponding at each stage when you're doing major connector, clasps, finishing lines. So again, I'm going to click on the major connector. I know it's Argon SLM, I can see it. Brings up your little pencil, and now again, we're going to obviously draw a design. So again, start somewhere, obviously move it all around the framework, and then obviously bring it back to where we need it. So again, this is maybe where I want to go back to my texture scan. And then obviously, here we go. Again, I think if you're getting used to CAD, it's always good to maybe just do continuous dots if you want to do, instead of continuously drawing. It takes a little bit more dexterity with the mouse. But as you can see, we can just follow our design. Because we got the anatomy element here, we need to obviously bring it into, so it's going to touch it somewhere. Because as soon as the major connector touches the pontic there, at least it will mesh together. And then obviously we're going to just obviously join it where we need it to join, right at the bottom there. As we've got the retention mesh here, it's highly important that obviously you can see where we've intersected the retention mesh. We've gone through the red line and we've come out the other side. If you hadn't done that and you left it at this, what you're going to do when you generate the STL at the end of the design is you'll get two separate files. So like I said, it's highly important that you actually go through the red line, you cross over through it, and then obviously you can bring it through. And so obviously that means it's obviously going to mesh over each other and obviously join together. So once it's all joined, all we're going to do is just obviously finish it to where we need it to be. Again, if you right click, you can go fast edit. There's an option there to have that option, which is obviously quite quick and easy to design if you feel comfortable doing it. Again, maybe you want to design it up here if you wanted to. It's quick and easy to design there. there are a lot of these X Pen type accessories you can buy online these days, obviously, which help, because obviously you can actually draw. I think we're all used to tablets these days. Again, I think this one's got a touch screen on here too. So as you can see on the laptop, I can actually draw it. I think a lot of people, so definitely if you want to explore those type of interfaces and how you use them within your design, you can definitely use that. So I'm just going to change that back there quickly. And again, the nice thing about the fast edit, it auto corrects it as soon as you draw it. So if you did need these areas, you just draw a line and it just automatically connects. You can use the major connector too. If there was rest areas, you can actually draw into those rest areas, so you can actually incorporate them into the rests. And then obviously just make sure that it has intersected somewhere in the retention mesh. And it's always good at any stage, you can always hit preview just to show you what comes up, because it's always nice to see what you've drawn. And then obviously from there, you can obviously then amend it as and when you need it to. That's it. Okay. And again, like you say, if you needed to extend some areas, you can actually come in here and just continue to draw where you need them. If that was a rest there, you could draw that. And again, any areas you want to sharpen up, you can sharpen up. But also, we can also then obviously open the palette as well. So if you wanted a skeletal type design, there's an option here for window. If you click on that one there, this little blue one down here, we can actually, let's change back to our design there, our texture scan. And by using that window one, all I'm creating is another open palette design. And again, just make sure you join the first dot you did, and then obviously just draw it to where you need it to be. Bear in mind, you don't want to make these connectors between here too thin. You need, at least with SLM, at least a 2 millimeter sort of for your junctions and your arms. So again, just make sure that with anything CAD, whether you're doing SLM or any of the other materials we spoke about, I think it's always good to be able to overcompensate, especially if you're learning, because it's always easier to work out something that's you can trim instead of realizing that when you've designed it, it's too thin and it's not obviously going to function because you wish you probably had more on it. So I always tell everyone, maybe just overcompensate slightly, and at least then you're not going to get, because what happens with the process when we do take these off the plates, obviously we build the SLM materials. There is a manual process to take them off the plates. So if these areas and your connectors and your minor connectors and your major connectors are too thin, obviously this is where they can bend and warp, and obviously then that's going to obviously create a ill fit and framework for you guys. So again, it's always good to just make sure that you do have those. You do have all these options too in your advanced settings on the right hand side. You can actually measure the thicknesses or the width of these areas if you wanted to. You just obviously draw, and obviously you can just use the measuring tape on there. Or like we said already, you've got your cross section. So if you are worried about thicknesses or frameworks, as you can see, with our SLM DME, the minimum thickness is 0.7. So 0.7, maybe 0.6 to a degree if it was a plate design. But as you can see, you can just measure, cut it in half, use the cross section, and then measure it in real time there. So you do have all these available tools on the right-hand side here, which you can use, which helps. So I'm just going to bring in the Pontic there on the right-hand side. We can see where that is there. So again, as you can see, the Pontics touch the framework as well, so that's all going to mesh together. We'll tidy it all up just now. And then obviously we're going to go next. So now it comes to the class, which is probably the next most important stage, other than obviously the blocking out. And then we can now look at how we're going to class these areas now. Again, if you look in the bottom left-hand side here, you're always going to follow obviously what you selected in the order page, which is obviously ARG and SLM clasps. So as we've got here, we've got an ACCA's clasp for either anteriors or posteriors. So I'm going to click the posterior one, click in the box, your pencil's going to come up. And again, what we're going to do is just obviously get ready to start the clasp. So we're going to start where we start the clasp and then obviously move around the tooth. So unlike all the other ones where we've been drawing and then joining the first dot up, with clasps, all you do is you use one line. So I'm just going to click, click, click. And then click the last dot. And as you can see, that clasp comes up. And then obviously it tapers off. And then as you can see, now you can move these to where you need them to go. But remember the undercut depth chart, because we want to keep, as this is going to be SLM, you want this to be in the yellow. You don't want it to go past that, otherwise that can cause a bit of a problem. And then obviously it's using a few hotkeys here as well. So if you do want to thicken up the clasp, you use Control. You can see it's moving it up. If you hold Shift, obviously you widen the clasp. So again, depending on whatever material you're using for your frameworks, you can design them to, obviously because we selected ARG and clasp here, it comes in with the recommended thickness and width. But again, like I said, maybe the first couple of cases you guys do, you might want to make them a little bit thicker, a little bit wider. And that will just make sure, obviously, when you get used to them, the more experience you get using the RPD software, is obviously you'll be able to just gauge these by eye eventually and just say, well, you can see where you need them to go and how thick they need to be. So again, you could probably turn off the point of where the clasp engages that last third. So we'll keep that one there. And then all we've got to do now is just make sure we join it to the framework. And then we've got a couple options here. So we've got the ARG and SLM minor connector. I'm just going to click on that one. And all we've got to do is just position that minor connector. And again, this is where we will use our shift and controls. So obviously, because this is obviously the area it's going to join that retention mesh, I'll probably start off a bit thicker, and then obviously you can control. If you ever need to add a dot either, you can also just right click and just go add point. And then obviously you can design it so you sort of get more of a uniform shape by just adding and removing dots if you need to. But again, it's just making sure each one's touching, and again, where the clasp is touching the framework, you just want to make sure. Don't worry about it all being a bit bumpy and everything here, because obviously we'll have an option to smooth that all off just now with our wax knives. But we'll just get it onto an area we want it to go. The one other little thing to bear in mind here too is, because we're doing these all model free, we're not going to have models. You're just going to send an STL, upload the STL, and we're going to make these. To guarantee the fit of these clasps, because we don't want these to be moving around anywhere, is we actually need to tag them in place, as we call it. So there's an option for, in the DME, for a jumper, which you see down here on the bottom left-hand side. And if I click on that jumper option, oops, sorry, let me just click back to the clasp. So if I click off and I go back to that jumper option down here, what I'm going to use that jumper for is just to tag that framework onto here, which all it's going to do is hold that clasp in place. So when we do the SLM build on the framework, it's going to stop it from flexing or moving. As I said, we've got a manual process to take these off, so you don't want that to actually move or bend when you do take it off. So we will cut that jumper off. But it's just there to obviously give a bit more reinforcement. It keeps the clasp in place, and obviously you guys are going to get back something that's going to fit and function. So add a little jumper. So anytime we add a clasp, or if there's anything extended or skeletal, maybe roaches or eye bars or anything like that, you can just add a little jumper. Another little obviously option with the jumper is you can actually click on the jumper. You can actually obviously tidy these areas up with it, which is obviously around the retention mesh. Maybe you just want to go around the edges. It serves two purposes. Obviously, it's going to make it nice and neat, your framework. But also what that's going to do is gives us somewhere to sprue onto too when we put it into the slicing software. You can actually sprue onto the perimeter. I know there's a little bit of a roll on there at the moment, but again, we'll have an option to smooth that all off with the wax knife just now. So again, we can put a little border around this side as well. Just join it up there. And again, we'll do the clasp on this side as well. So let's have a look for, we've got a Acker's posterior clasp. Click on the little box. And again, we're going to keep it within the yellow coloring because that's where the undercut chart was. And again, if you want to just stick in certain areas, you can just use the shift or widen it. Okay. And then we just need to join that to the major frame as well. So you could use it. Again, we'll use our wax knives to smooth it all off and clean it all up if we wanted to. But if you have a look in the different drop down there's many different clasps. You've got different clasps for roaches, for, like I said, your E-class, your G-class, your uniform class. Anything you can sort of download as a DME, you can put it onto the system in this 3Shape. If you do have a look in the control panel, I'll just try to get it up there. I'll just show you where those options are in your control panel. If you go into the removable section in your control, open the control panel, there's all the different options here. So you can actually click Save for Frames. You can actually control your own, obviously, DMEs. Obviously, like I said, I wouldn't advise going below any of the parameters of the actual Argon SLM. But again, if you wanted to create your own type class where you probably prefer them a little bit thicker or maybe a little bit wider, you can actually do that all here. And then obviously anytime you do anything in the control panel, just make sure you save. Make sure you obviously keep it closed down the top here. When it asks you, confirm, just say yes. And then the next time you open your dental system, you'll have your own type of class profile in the actual settings. So, but as we can see, we've got the class there. If you wanted to, like I say, again, it's just making sure you tag it on anywhere where there's going to be a tag on. We'll blend it all in just now. You could just add a little jumper there just to make sure that it doesn't move there. As we said, our guys are normally trained to know where the jumpers go, so obviously we'll just cut those off. But again, it's just making sure that that's going to be that clasp is going to be held in place. So when we do go through the whole manufacturing process, it's not going to move, it's not going to bend. But let's go next then into sculpt. And this is the areas here where we can use the different tools, our wax knives, to blend, smooth it all into place. sort of take any creases out if we need to take any creases out. I think if you see the SLM frameworks that Argon have got on display in the front there, they've got a really nice high mirror finish on them. So if you do use your smoothing tool at this stage just to take out all those little creases and kinks, and sort of the higher quality of the polish, it all determined by the smooth off you're making it at this stage. Yeah, so if you can make it as smooth as possible, as neat as possible, you'll get a far nicer framework at the end of it. Again, just bear in mind, if you are using the green tool, the smoothing tool, just make sure that obviously you're not using the intensity too high, because it can take away if you need to. So again, if you are worried, always just add a little bit to certain areas where the joins are, or the clasps are going to be. And again, if there are any areas, like you say, you're worried about a stress point, I would always, as I said, just add a bit of material onto those areas just to make sure. It's a lot easier to tickle it when it comes back than to realize it's too thin and it's moving around. So, okay, let's go to finishing lines. Down the bottom left again, we've got a couple options for finishing lines. We just got to click in our finishing line box. The pencil will come back up. It gives you an automatic sort of a guideline of where the finishing line is going to be, the green line. So I'm just going to follow. You don't have to follow where they've put it, but you can just obviously pop it where you need that to go. And then just easy to manipulate. Same on the other side. You can see there's a green line. It's warning us there's one there. So we're just going to. You just got to bear in mind, sometimes the finishing lines do come in the wrong orientation, just like that one. So if that ever happens, you just got to right click and go reverse spline, and then it will just reverse it back into position. And also what you can do is, obviously, because we go through that rotating polishing unit, I do recommend sometimes by using your shift or your control, you can just make those areas a little bit wider, a little bit deeper. So what it does, it doesn't polish away when we do put it through the medium dry polishing process. So just sort of scroll them up a little bit just to make them a little bit wider. Obviously, our pontic here, we don't need a finishing line because we're going to add some retention in there. And we can go next. So you do have another option for sculpting at this stage now. So if there's any final sculpting at this stage, you might want to, just reinforce behind those finishing lines. You might want to just add a little bit of material just so it gives it a bit of strength there so it doesn't polish away too much. Again, maybe you just worry about some of those joins or connectors, junctions. Just add a bit of material. And this is where obviously you've got your options here for attachments as well. So you can actually add all your different, so there is an actual category here for partials. If you click into partials, you've got options for like your wire posts, your springs, your cylinders. So again, if you had any sort of in the anterior region, you wanted to pop in one of these wire type posts, you can actually pop them in there, position them to where you want them. What I will advise, if you are going to add any of these type of attachments, is to always just right click and then add base, because if you add a base, then obviously that's going to give you extra. So when we do remove those supports, we're not going to take off any sort of attachments by accident. But as I showed you earlier, we brought in that try-in. So remember, our try-in is still there. So this is where you got a great guideline. So if you did want to design something with backings or retention posts, where if you wanted to have some cylinder type or spring type posts, but where your teeth are going to go, that's where the try-in comes into its own here now. So you can see where those where your virtual teeth are, and then obviously you can see then where you need to put those. Maybe you wanted, for example, put a parametric shape. There's a cylinder option. You can click on that, and then you can actually position it on your frame. If you go by surface normal, you can actually position it to where you want it, and then actually you can draw and how thick you want that post to be. So again, if you wanted some extra support and retention, you can do that with the guidance of your pre-op or your wax try-in or existing denture. And as you can see, it comes in quite nicely if you did want to have some sort of a extra support like that. It works great for backings. It works great for sort of, your anterior teeth areas where to put those springs and Y posts. So again, let's just have a look. So the benefit of 3D printing is obviously if we say we want to look at this post spring here, if I just add one on here just to show you, as you can see, you've got that coil retention mesh, that coil retention. If that was milled, you wouldn't have that fine, precise detail. Same as the Y post, because with the mill, it can't mill in all those intricate areas. But because it's 3D printed, that will print like for like, and then obviously you'll have that extra retention on there. So again, another positive, obviously, of the additive process over the subtractive process. A nice little feature too from 21 and above is obviously you've got option for stippling now too. So you could actually draw the areas you want to stipple now by selecting that green icon, and you can actually just click play. And as you can see, you can get these stippled effects here too. So there's a whole lot of different stippling options there. Bear in mind, if you are going to use stippling, it doesn't give you that high, nice shine you get out there with your mirror finish if it was smooth. But again, if you did want to have those stippling options, you can use that. And again, you can just control the height of the stipple here to make it as subtle as you want or as aggressive as you want it. So it's a nice little feature that's come out. As well as the little feature that's come out also with the stippling was the option to actually put ID tags as well. So again, maybe you wanted to put a patient name, or maybe you wanted to put a number. You can just pop the text in there. Because it's going to be 3D printed, they're perfect to engrave. So you just obviously draw whatever or write whatever name tag you want on there, just position it where you want it, hit the play button, and then obviously, even though that looks like it's standing out, that will be engraved. And again, once it's gone through the polishing process, it does just make it all nice and smooth, so it's not going to affect the mouth or the tongue in the mouth. If I click on attachments here too, there's another neat little function too, which has come out, is you've got this option here. And a lot of people now, we're noticing in the UK especially, they've managed to create the STL file of their lab name, for example. So they can actually sort of turn it into an STL. You can actually add it into your control panel or put it onto the attachments, but you can actually bring that in at any stage. So if I click on that, say for instance, we've got the argon. Just going to position it quickly. But you can actually position your own logo if you do have the option or facility to do that. And it's just a nice little gimmick or a nice little function, especially if you are designing them. It just goes to show you the options that you can do if it is going to be 3D printed, either in a castable resin or yourself, you want to send it to an SLM manufacturer. You can actually incorporate these other little ID tags and your own unique sort of spin on your frameworks, which is quite nice, like you say. And again, if it was sticking out a bit, you can just use your wax knife and just obviously make it a little bit more subtle. So when it does come up, it will come back nice and smooth. But it gives you a nice little option, especially like you say, if you've got a logo you want to incorporate patients' names, case IDs, you can do that all with SLM. So just moving on to the last couple of steps here is obviously pre-manufacturing stage. Again, a nightmare to do in the lab on your own is obviously you've got the options for tissue stops. So this option here on the left is obviously you can control the diameter of the tissue stop here by the click of the button. just click the plus button just to add it. And you can actually just click where you want the tissue stop to go. And if you hit preview, as you can see, you've got a perfect little tissue stop, and again, you can control the diameter to how you want that to be, and that'll be a perfectly accurate little tissue stop on there. So any freehand saddles, you can use that option there. What you can do also, especially if you're going to be printing these yourselves in-house, one of the things you need to just bear in mind is obviously you need to obviously get that support across the, especially if it's going to be lowers or any delicate designs. And this option here on the left here gives you options for support bars. And as you can see, you can just add support bars to where you need it to be. On a case like that, I would suggest probably 2 support bars if you're going to be casting in a castable resin. With our manufacturer, we would normally put these on ourselves in the slicing software. But if you were concerned about movement or warpage, you can put them on yourselves. And then again, draw where you need them, hit preview. And then obviously they'll just come into play there. So again, some people use these for options, you know, to create a spring tree. You could just control the diameter if you wanted to, and you can actually, because it's 3D printed, if you're going to use a castable resin and your printer has a Z-axis, you can actually create your own sort of a sprue formation if you wanted to with that. It's quite a neat little option. But what I'm going to use these options for here now is just to create that bit of retention mesh or retention that we want, mechanical retention in that facial veneer. So again, I'm just going to put a little bit of a cross sort of shape in here. And then what you can see is when it all joins, because it's going to be 3D printed, that will print like for like passive process. So when it does print, you'll have that nice wraparound retention in there. I'm just going to hit preview. If that was milled, you'd probably find that it would probably not print in that area. Or probably wouldn't mill in that area because it can't go through all that sort of complex design. But if it's 3D printed, no problem at all there. So, but again, you can make these designs as advanced as you want to make them. You can make them as complex or as simple. 3Shape has all the tools available. It has all the tools available on the right-hand side. Like you say, you've got options to bring live photo cases in. You've got options to bring try-ins in. You've got options to bring your virtual design in, your diagnostics. So again, it's a great little feature. Like I said, there's loads of videos, loads of tutorials. If you guys ever go into 3Shape community, there's some great little features on there you can follow. It's all free available now. But that's basically in a nutshell, just giving you guys a couple tips and tricks here just to get your 3D printed RPD done. Just to go back to the final presentation before we round off there, it's just obviously, let me just get it up. And that's basically it, guys. Like you say, if you get the design protocols right from the very beginning, you follow the stages, you can get a very good precision fit, high performance. We know the functions there, the quality's there, the product. But the biggest thing for you guys is obviously the reduction in costs, time, labor, especially now with the lack of experienced techs in the market or the lack of, like I said, I know in the UK how short we are for skilled cobalt chrome technicians. If you can do this in-house for you guys can have a brilliant product that you guys can use. Argon obviously supplies it. We know the quality of their outsourcing. Like you're saying, it's going to be a perfect sort of there's many studies online. If you go in there, like you said, in the Journal of Prosthetic Dentistry, showing you all the different combinations of the strength, obviously the trueness of the RPDs additively manufactured against the castables. And obviously also there's a lot on there on about the patient comfort, the overall stability. So there's a lot on there you can actually see, and why we're using digital for these RPD solutions, because I think that definitely the pros are starting to outweigh the cons. But if you guys can get the designs done, and like you say, using all these sort of other sort of options you've got with 3Shape, Exocad, you guys will get a great product back at the end of the day. So, but like I said, it's thank you for your attention, guys. Like I said, I think, like I said, it's been a good couple of days. I know you guys have been here right to the end, so I thank you for your time, because, like you said, I think everyone sounds like they're knocking down and moving on. So, perfect. But thank you very much, guys. If I am around here, if you guys want to come have some chats, like I said, just to talk about any of the 3D solutions or RPDs, like I said, if there's any tips and tricks you want to know, come grab me here down at the table. But thank you again. Hope you guys have a safe trip or wherever you guys are going, and enjoy the rest of your Saturday.